Hi everybody. So making a video for section 4.1 and it's about linear functions. So a linear function is a function that you might know of as f of x is equal to mx plus b. You probably learned it as y is equal to mx plus b. And the notation is basically similar, and this is notation that says yes, it is a function. And this location is basically keeps track of what number you're plugging into this function. This piece here is your slope, or what is referred to as your average rate of change. And this piece here is an indicator of your y-intercept, where your y-intercept is 0, b. Now, a function can be, a slope, still, a line can be increasing, decreasing, or constant. So if you have y is equal to 3x plus 4, your slope is the 3, and we put it over 1. We report it as a fraction, so it's 3 over 1. And then our y-intercept is the ordered pair 0, 4, where b is our 4. Now, a decreasing function would have a negative slope, like negative 1/4. Okay, and a constant function would be something like y is equal to 4. So why is it constant? Well, let's take some ordered pairs from this. Now you can choose your x values, and no matter what x value you choose, your y is 4. So that's going to be 0, 4, 1, 4, 2, 4, 3, 4, and 4, 4. You may ask what happens if it's like x equals 2. Well, you can still treat it similarly, but it's not a function. It violates the vertical line test when you graph it. But in this instance, you choose values for y, and you say, well, what is x going to be when y is 0? Well, it's 2, because x always equals 2. Up here, y always equals 4. So this is 2, 1, 2, 2, 2, 3. And if you graph these functions, here's your x-axis, here's your y-axis. No matter what your x value is, your y value is 4. Here, no matter what your y value is, your x value is 4. So that brings us to, well, what's the slope on this and what's the slope on this? Well, recall that the slope formula is y2 minus y1 over x2 minus x1. And if we take 2 points and we treat this as the first point, that is the second point, we'll have 4 minus 4 in the numerator, because it's the y of the second point minus the y of the first point. Then it's the x of the second point minus the x of the first point. So we end up with 0 over 1. So this actually is referred to as 0 slope. Okay? This one, and we'll take these 2 points. So our y2 is 1, and our y1 is the 0, and then it's 2 minus 2. Well, we end up with 1 over 0, and we've talked a lot about not being able to divide by 0. This is referred to as undefined slope. Okay? When we describe slope, we never say no slope. We either say the slope is a fraction, we have 0 slope, or we have undefined slope. Okay. Now, going back, constant, decreasing, increasing. Increasing because the slope is positive, decreasing because the slope is negative, and the slope is 0, so it's a constant line. It's just straight across. Okay? All right. Turn the page here. There's this thing called, oh, I got to do this real quick. So I got to mark where I can't write. Okay, so here, this thing's called an average rate of change. And on a linear function, the average rate of change actually turns out to be the slope, and we'll show you why that's the case. So suppose we have some line, and what we're going to do is we're going to take two ordered pairs on this line. We're going to say f of x2, mx2 plus b. So we have a second x value, and we've plugged it in, and we've gotten a y value, a second y value. Here's f of x1, mx1 plus b1. Now note, this is the same line for both of these equations. So the m's are the same, and the b's are the same. Now, the argument is that the change in y over the change in x, that's our average rate of change. And what we're going to do is we're going to say, well, the change in y is f of x2 minus f of x1, which you would know is y2 minus y1. And then x2 minus x1 is in the denominator. Well, that piece is just that piece. So we have mx2 plus b minus, and whenever we're substituting in, put it in parentheses. So then we have mx1 plus b over x2 minus x1. Well, we distribute our negatives, right? It goes to both. And so we're really looking at mx2 plus b minus mx1 minus b. And the b's are the same, so they eliminate each other. And so we're left with this mx2 minus mx1 over x2 minus x1. And if you look, both of those m's are the same, so they'll factor out. And so we have this x2 minus x1 over x2 minus x1. And since the whole piece cancels, can't just cancel part of an addition, you end up with m. So the slope actually is equal to the average rate of change. And so if you get this equation where it's f of x is equal to 3 over 2x plus 4, and they say, what is the average rate of change? It is the same as the slope. It's that thing. So it's the slope. It is also called the average rate of change. All right. So I'm going to do a couple of problems now. And again, right about here is where I can write. All right. So the first question is here's our f of x. It's number 13 on page 287. You have 2x plus 3, and it says, what's the slope? Well, slope is 2 over 1. What's the y-intercept? It comes from this, and it is 0, 3. Okay. What's the average rate of change? Well, the average rate of change is the same thing as the slope, so that's the answer there. And determine whether it's increasing, decreasing, or constant. Well, the slope is positive, so it's increasing. Okay. Now that's number 13. Let's look at number 21. And it asks, is this a linear function? Well, you have -2, -1, 0, 1, and 2. These are the x values. And your y values, or your f of x values, are 4, 1, -2, -5, -8. Well, the difference between all of these is a difference of 3. And in fact, it's a difference of -3. So they're going down 3 each time. And all of these are units of 1s. So the distance from these are all the same, and the distance from these are all the same. So you can write it as y is equal to -3 over 1, because it's the change in y over the change in x. Now, plus the y-intercept. The y-intercept always has an x value of 0. And so if your x value is 0 and your y value is -2, your y-intercept is -2. I have to stop here.